Let's go ahead and look at some of these files that are used to manage the passwords and users. First one is going to be etc passwd. So this is a text file that contains the attributes of each user or account on a computer running Linux or another Unix-like operating system. So the permissions for etc password are by default set so that it is world readable, meaning that it can be read by any user on the system. The file can be easily read using a text editor such as gedit or vi, or with a command such as cat, which is commonly used to read these files. And that's how I typically look at these files, is through cat. Or if I want to actually have a little bit better output to look at, I'll use vim. So we would just do cat/etc/password to see what's in these files. And guys, we've actually looked at this before, but I'll go ahead and show you again what that file looks like. Do Control L, we'll do cat/etc/passwd. Alright, and then we see a lot of output here. Okay, each line is going to be a different user, and it's going to have different traits to it. So we see here root, its password, min-max days, groups, its shell, and its home directory. Okay, so it gives a lot of info about the users. Let's go back to our PowerPoint. So each line in etc password represents a single user. The first line listed is root, which I showed you. And this has complete power over every aspect of the system. Root is the super user. It rules all. So this is followed by system-defined groups, meaning that they aren't necessarily users. They're actually, I guess the best way to put it is they're just accounts on the system that control certain things on the system, okay? Which that says here, these are accounts that are required for proper installation and update of system software. So in order for some of these daemons to run things on the system, they need to have an ID and a way to access the system. So the lines at the end represent real people who use this system. So real quick, let me see if I can show you. Yeah, there you go. You see at the very end there, you see kdowns. So that's going to be me, my password, my home shell, and my home directory, okay? So at the very end is where the actual users are. So let's take a look at our next file, which is going to be the etc/shadow file. Okay. Traditional Unix systems keep user account information, including a one-way encrypted password and a text file called /etc/password. Okay, which is the file we looked at. So since this file is used by many tools such as ls to display file ownerships, etc., by matching user ID numbers with the user's name, the file needs to be world readable. Okay. However, this is kind of a security risk. If we're storing our passwords in a world-readable file, then anyone on the system can see the passwords, okay? So we have a much better method of actually storing passwords, and that's going to be the shadow password format. So with this traditional method, the method stores account information in etc password file in a compatible format. However, the password is stored as a single X. So let me show you that real quick. So you'll see there right next to all IDs and names, you see an X, okay? So that's the password, but that's just a placeholder for it. Okay? So in a second file called /etc/shadow, this is where it contains the encrypted password as well as other information, such as account or password expiration values. The etc shadow file is readable only by the root account and is therefore less of a security risk. So let's check that file out. Let's clear my screen here. I'm going to do cat/etc/shadow, and shadow is kind of, mysterious. Oops, so I need to be root user or super user to do that. So I'm going to go ahead and switch over. See, that's another security measure for this, is that it's not a world readable file. So you have to be root to do it. So that means even if someone was on your system, they would have to be root to be able to read it. Alright, so now we see on here, let's go to my user right here. So you can see there, my user's at the bottom, and then we have this huge string of numbers and letters and symbols here, okay? That's my password, but it's encrypted. So even if you get into this file, you can't see my password in plain text, okay? You'd actually have to run an algorithm to unencrypt it, which would take time and knowledge to do so. So setting up passwords in this way is a much better way to secure your system. Let's look at the etc group file. This is a text file which defines the groups to which users belong under. Linux and Unix operating systems use this method. So under Unix Linux, multiple users can be categorized into groups. Unix file system permissions are organized into three classes: user, group in others, which we've looked at. The use of groups allows traditional abilities to be delegated in an organized fashion, such as access to disks, printers, and other peripherals. So this method, among others, also enables a super user to delegate some administrative tasks to normal users. So guys, I can put a user in a group, and then I could say that group has certain privileges to files, certain access to certain directories, or maybe they can only run certain commands. So that allows me to more efficiently kind of administer my users on a system, as opposed to going each user one by one, saying this guy can do this girl can do that. I can just make a group, give it certain permissions, and then throw everyone I want in that group to have those permissions. So let's look at the etc shadow file. As you might imagine, this is similar to the etc password, etc shadow file. So the etc shadow file is readable only by the root user and contains an encrypted password for each group, as well as group membership and administrative information. Just as in the etc group file, each group's user information is in a separate line. So let's look at both those files. Let me clear my screen. We're going to do etc group first. So we'll see all the groups listed there, and then the little X for the placeholder. And let me clear my screen, and let's do a gshadow file now. And then you'll see all the groups on there, and then with the exclamation point, okay? So this means not, so it does not have a password. Bang in Linux usually, bang is another word for exclamation point in Linux. This usually means not, okay? It does not exist. Clear my screen. Another little helpful command, guys, is the groups command. Oops, forgot the S. This will actually list all groups on your system. In this case, there are no groups other than root. So that's handy if you're trying to think of what groups on your system. You can run the groups command. I'll actually add that in here. So let's go ahead and move on from here.